Good afternoon, students. Myself Sushmita, Assistant Professor, ECE Department, RCET. So, in this video, we will be seeing about Schottky Diode. So, on completing this video, you will be able to understand how Schottky Diode works, that is, on which principle it is working. Second thing is, you will also be able to explain the construction of Schottky Diode. You will also be able to list out the advantage and disadvantage of Schottky Diode. So, now let's see one by one. So first let's see a small introduction about Schottky diode. So Schottky diode is nothing but it is a small electrical component. We can call this Schottky diode as barrier diode. So it is used in various applications like mixer, radio frequency application, and they are also mainly used in rectifier for power amplifications, and it is a low voltage diode. So coming to discuss about the Schottky diode constructions, application characteristics and its advantages. So now let's see a short introduction on Schottky diode. So these Schottky diode mainly used for creating a Schottky barrier. So here we will be having an N-type semiconductor which will be acting as a cathode, and there will be a metal which acts as the anode of the diode. So you can see in the PPT it is represented as anode and cathode. So this particular Schottky diode is also called as hot carrier diode, and it will be having low voltage diode. So there normally the voltage drop of this particular diode will be ranging from 0.15 to 0.45 volt, and there is a low voltage drop which produces higher switching speed, and there will be a better system efficiency. So in general it will be having a semiconductor metal junction which is formed along the semiconductor and a metal. So next one is Schottky diode construction. So it is an unilateral junction. It will be having a junction at one end and another metal which will be formed at the another end. So between these two regions it will be having an ideal ohmic bidirectional context where it will be having no potential between the metal as well as the semiconductor. So this Schottky diode is simply a function of temperature doping. So in simple words we can say that when doping concentration is increased, then the temperature, that is the temperature doping concentration, will be increasing, and it will be causing the semiconductor concentration to decrease. So this is the construction of diode. So here you will be having diodes like molybdenum, platinum, chromium, tungsten, aluminum, gold. All these things can be used as a semiconductor in n regions. So Schottky barrier diode, this particular diode is also called as Schottky or hot carrier diode. So this is a metal semiconductor. So how we are going to form is, it will be creating a junction by bringing both the metal into contact, and we are going to dope n region semiconductor moderately. So by adding this Schottky barrier diode will act as an unidirectional device. So unidirectional in the sense it will be having the flow of current along only one direction. So this is the graph representation. So we will be having Schottky barrier metal, and we will be having back contact metal and NAP layer. So it will be having a front metal along with SiO2 passivation, guard ring, N plus substrate, all those things will be taken. So coming to the VI characteristics, you can see current and voltage. So when voltage increases, current is also increasing, that is represented by the graphical representation. So in detail about VA characteristics of Schottky barrier diode. So the forward voltage drop of Schottky barrier diode is very low when it is compared to normal PN junction diode. So this voltage drop will be ranging from 0.3 to 0.5 volt, and it will be having a forward voltage drop which is made up of silicon. So voltage drop increases at the same time when it is increasing the doping concentration of N-type semiconductor. So VA characteristics of Schottky barrier diode, we can say it is very steeper when it is compared with the VA characteristics of PN junction diode, since it has the higher concentration of carriers. So next one is application of Schottky diodes. So Schottky diodes, it is mainly used for voltage clamping applications, and they are used for preventing transistor saturation due to high current density in the Schottky diode. It also has low forward voltage drop in the Schottky diode. So when it is wasted in less heat, then it will make it efficient choice such that the applications are made as sensitive and they are very efficient. So this Schottky diode are also used as a rectifier in power supplies. So next one is advantages of Schottky diode. So mainly they are used in many applications when compared to other diodes. But first thing is low turn on voltage. So low turn on voltage in the sense mainly we can use for operating in the terms of 0.2 to 0.3 volts, whereas in silicon diode it has to be made up to 0.6 to 0.7. So that is the advantage of Schottky diode. So next one is fast recovery time. Fast recovery time is nothing but it will be having a small amount of stored charge which is used for high speed switching application. Next one is low junction capacitance. So it will be occupying a very small area, so such that the result can be obtained when it has an wire point contact with silicon. So next one is features of Schottky diode. So it will be having higher efficiency, low forward voltage drop, low capacitance, and low profile surface mount package, that is ultra small. Next one is integrated gathering for stress protection. So on general concluding this, we can say that it is used for various working principles and applications. Also we have seen about the construction, Schottky barrier diode, VA characteristics. So still if you have any doubts you can do drop me in the comment. Thank you.